This podcast is produced by OnPod, a video content studio near you.
You've worked on aerospace, medical, and assistive robotics. If you had to explain your mission to a non-engineer, what's the common thread tying all your projects together?
I think the fact that I do mostly robotics, most of them, doesn't matter in different applications. Typically, you design a robot and then you gear that robotic system or you spec it to that application. But at the end of the day, it's moving parts, it's controllers, it's software, it's electronics, it's mechanical. So a lot of I would say, developments are pretty similar. But definitely different applications have different requirements, so you just have to customize to that application. So I think in terms of the process, it's all the same. And that's pretty much the common thread in a lot of those.
Based on your years of research, how do you decide which problems are worth solving with robotics?
It depends. We have long-term projects that are more of discovery style. For that, we get maybe large grants for over a few years, 5 years, 6 years. So those ones we actually define. We do studies here and there, and then we probably have some background and we check what project is nice, and then we define, we write the proposals, we get the funding, and that's good. I call that discovery grant. And then there's the other ones that industry comes up with a need and then says, can you solve this problem? And we have that as well. So some of our aerospace projects are like that. The companies come here and say, we have difficulty machining this part, it's part of an aircraft, high precision, high tolerance. Can we work on that? And then we just say yes or no, and we start doing that. So different problems come from different sources, but definitely the ones that is more in our control are the discovery style, where we say, okay, here's my interest in medical robotics or aerospace because of the challenges that they face,
Right.
And the complexity of the design process. Then we basically spend our time on the discovery style project on those type of challenging problems that needs talent, needs time, and whatsoever that it takes to do that project.
Yeah, that would be definitely dangerous if you messed up. What I was thinking about was Elon Musk and his Neuralink. Like, if that didn't go well on humans, then, the results could be catastrophic, obviously. So I could see how...
Those are really long-term projects.
Okay, yeah.
It needs a lot of trials, needs a lot of safety regulations to be passed before you can actually put it on the human.
That makes sense. Do you find when you do projects sometimes that the regulations aren't matched up to the discoveries you're trying to discover? Like,
definitely when it comes to medical particularly, there is regulation. And we have other challenges as well. It's not just regulation.
Maybe ethics?
Ethics, for sure. We have to get ethics, especially if a hospital gets involved. You have two organizations to get the ethics from, your own school and also the hospital. But it's not always that. We face other problems as well. Like, for example, our medical system is pretty loaded. Our doctors are busy working with patients. How much you can expect from them to come into the team and start contributing? Definitely, there are ways that relieve some of their time, but that's one complexity that exists with the medical system.
Yeah.
And another challenge that we have is definitely complexity of the trials and testing. There are so many of us researchers and innovators. Would you have time to try all these new ideas that people come up with? No.
Right.
You can't, right? So we can come up with ideas every day, but is there enough money? Is there enough time and effort from medical to go through everything that we think of they would be trying? No. So there's definitely some screening process, some collaborations, and problems have to be defined very well from the beginning. Should be based on needs. There should be a lot of meetings before you just come up with a project and just run away with it.
Yeah, definitely.
So there's a lot of challenges when it comes to those applications.
Yeah. Okay. This is a little bit maybe off topic, maybe not. But in that way, have you heard of decentralized science?
Not as much.
Okay, fair enough. Because that's another source of funding, I guess, because right now everything's funded through universities, especially with large projects that have to be long-term and require a lot of funding and to go through those legal loopholes and bureaucracies to get everything done. But I guess open science decentralized science, in my viewpoint, sometimes it's a little bit less ethical maybe because you're getting funding from all these sources that you can't really, I don't know. Anyway, so not too much into decentralized science right now.
I think it probably would help with certain things, but not with many other things.
Right.
I guess if you have a lot of sensitivity in the application and there's high risk, probably those might be problematic.
Right.
But in a lot of other things, many things that I do is around rehabilitation. So it's not as sensitive as a surgery or a medical device that is used in surgery. So those type of things that I do might actually benefit from something like decentralized medicine.
Yeah, fair enough. Yeah. So speaking of which, you're developing intelligent assistive devices in rehabilitation robotics. How exactly can this technology help people with disabilities or in recovery?
We have several projects, but as an example, we designed a mobile robotic system. We call it Intelligent Mobility System. So that one basically helps people walk. And these are the people that are prone to falls. So if they fall, they break head, bones, whatever. Particularly people that are very vulnerable, all the people that are coming out of a heavy surgery in the hospital, and they could fall. And falling patients in the hospital is a huge cost, as well as elderly at home. So we developed a mobile robotic system that the patient gets connected to, and that mobile robot is going with the patient, detects the intention, and follows the person, holding and following the person, so prevents the falls, so reduces the chance of injuries and whatsoever. Also in the hospital, when a patient is supposed to go through early mobilization, which is a practice that every patient has to do to recover faster and get out of the hospital sooner, that requires, if you don't have such devices, requires people to be around that patient. And then a lot of nurses themselves, they're prone to falls, they're prone to creating back pain and lower back pain, and that causes being time off work and so on. So overall, the assistive device that we develop, for example, for the assisted walking, is one such device that helps the medical system.
Cool. That's amazing, really. So the idea of human intention detection, that sounds really futuristic. Can you explain more about how it works and what kind of breakthroughs it could lead to?
Definitely. In short, we basically collect information from human. The things that we typically, as another human, we won't be able to see. For example, we connect probes to the muscles, and we pick up the small voltages that muscles generate, called electromyographic signals, or EMGs. So what we do, we basically process that information. We create some features, we call them features, but some functions. We do a little bit of processing, create some smaller dimensions. These signals are many and they're large in time. So we create some features by doing some mathematical processing. Then we use AI, I would say, or machine learning, or a computer, basically, a computer program. Then we give all these signals, and we say, at this point, this person had this intention. So basically, you're training the machine to learn how these signals look like when the person wants to go right or left or forward or stop moving or sit down or stand up. So gradually, we teach the machine what the person wants to do and give also the signal. So machine learns when these commands come in, how the signals look like. And then in reality, once the machine built that model, then in real time, when the robot is helping the person, the signals are coming in. The machine knows how to interpret those signals because it has seen it before. So now the AI is trained for that kind of process. So every AI application needs some training where you collect data, you teach the machine, and then later on, you ask the same machine to to perform in the same way. So basically, we get the person to walk around, we collect the signals, we have all the commands, and then after that, then that computer that controls the robot knows the intention of the person based on the signals that it's collecting from that person, and then the robot collaborates or cooperates with the person. So that's one of the intention detection projects that we have. And this is for assisted walking. We're implementing on the same robot that I mentioned before, called SoloWalk. We do have also the same process, EMG intention detection, for exoskeletons, which could be for patients, could be for anybody performing any task. Imagine that you have this robotic suit that you can put on, and then it's picking up your muscle signals, and it knows what you want to do, and it helps you with picking up the load. For example, in a warehouse application, you're lifting heavy boxes. The exo is supposed to help you, but you don't want to sit down and program all the motions of the robot. You want the robot to automatically work with you.
Right.
That interpretation of what you want to do through your body motion, through your body signals, is where the intention detection happens. And we use the same principles as I mentioned before. Obviously, we have other projects as well, but all of them have this repeating theme where you pick up the signals, you train the machine, and later on machine basically uses the same signals to decide or interpret what is your intention and help you out.
Right. So there's a lot of data required for that then, and it's only possible because of AI now with machine learning. I feel like those suits would be heavy too.
Well, depends how much load you want to put on them. But definitely there are postures in your body. They don't have to be very heavy because they could provide partial assistance.
Okay.
You don't necessarily have to do everything with that. If you want to do everything with the robot, then you don't need to be there. Mm-hmm. But the human being in the loop, the good thing is you can actually command. You can create all the motion. But the question is, how does the robot follow you? How does it know what you want to do so it doesn't fight with you? It actually helps you.
Yeah.
So the robots don't have to be very heavy, but there are bad postures in your body as well. So if it provides only at those critical moments where you're bending over to lift a box, there are some critical points that you can get the help at that point, and then the rest, the robot doesn't have to work hard. But definitely what you mentioned is a problem. So the heavier the robot, the bigger power supply it wants, the heavier again it gets. So it's a kind of a loop or a snowball effect that you want a stronger system, it needs more power. You put more power in, it gets heavier, then it needs to be stronger again. But you have to work within the limits that you have. Not every piece of technology in robotics has advanced so far that you can pretty much do whatever you like to do with the robot, just like, iRobot movies and those kind of futuristic stuff.
Yeah, fair enough.
Yeah,
okay,
yeah.
Cool. So how do you balance innovation speed with the rigorous safety testing required for medical and aerospace robotics?
I think if the application is regulated, you just have to abide by it. You have to live with it. Mm-hmm. The way to maybe accelerate it, there are some parts that you can accelerate. There are some parts that you cannot accelerate, but the tools to accelerate, first of all, a good funding mm-hmm. and good talent and good number of people working on it. But even if you had all of those, there are certain things that don't let you just throw more money and more people into it and just, do it very, very quickly. Some things need time to be matured up. And I have done quite a few of those applications as well. Lead time for components. Whether you have 100-person or you have 20 people. Mm-hmm. When a advanced motor takes 6 months to arrive, it takes 6 months to arrive. So if you have 100 people, you have 100 people waiting for that part. So it's not as simple that you just say, throw more money in and more people in and you get better results. Some places it helps, and some places it doesn't. But one thing that would be very helpful other than those is thinking from the beginning, working with the people that have the need. Need identification, I would say, is the main issue. If you're developing a medical device, you want to have the medical doctor on board. You probably want to have some of the patients on board, depending on the device. But you definitely need to talk to the end user, need to talk to the users of the device before you attempt to build, and then realize, oh no, that's not exactly what they needed.
Yeah, I guess you really have to fulfill what's highest in demand as well at that point, right?
Yeah, exactly.
Okay. Have you ever had to abandon or rethink a project because the technology just wasn't ready yet?
I can't say I abandoned any ideas because I fall in love so much with whatever I do that it's hard to say I don't want to do it or abandon it. But I did have one project that I left it for the future because first of all, it was a bit more complicated. It needed a lot more collaboration with the medical community, and also other priorities came up, other projects popped up. So that was part of my long-term plan, but then other immediate needs come up that sometimes you leave that. And that was, for example, a balance detection system where it alarms the person. We did some of the research, but then we did not continue just because the timing was not right to do it at the time. But it was a device that you would connect. It had vibrotactiles, and if you have a bad posture, it would help you detect those postures and avoid those postures. Basically, balance assist.
Okay. And that's a project that you put to the future? Like you left it for a while?
Yeah, we did some research, but then other projects like stroke rehabilitation and, mobility system kicked in with the proper timing and medical community right at it. Yeah. So we went with that, and then this project got delayed. So it is important, but at the same time, it's just you have so many different projects, so you have to sometimes go with wherever lowest hanging fruit or where the facilities are there, and try to get there as soon as possible.
Yeah, go with the least resistance, I guess, right?
Exactly. Yeah.
Nice. So you also teach at Carleton University. How do you bridge what happens in the lab with what students learn in the classroom?
Well, in the classroom, definitely all of us, all professors, they do have experience, they have labs. So they use a lot of examples in the classroom and stories. I have a lot of stories that I say in the classroom. If I'm teaching control systems, I talk about all the mishaps and the importance, all the things that could go wrong to get the attention of the students. But definitely labs are very helpful. So if you have more labs with more lab time given to each student, that would be very helpful to close the gap. The one thing that I'm doing more often these days is I use simulation assignments. Because computers have grown, simulation tools are grown as well. So a lot of problems that I want them to do in reality, some of them I can simulate and tell them, hey, look, why don't you just build a simulation, work with it. Let's say it's a robot, you're doing a trajectory control on a robot. We can definitely build the simulation. I want them to maybe design some wheel rolling down the hill as part of the dynamics course. I asked them and they simulate. And there are lots of simulation tools. So that has started becoming an interesting tool that maybe 5 years ago, 6 years ago, that wasn't on the table. Now that's on the table. But one more thing that we do in our last year at Carleton, which is an amazing thing, is a big project in the capstone. It actually puts a lot of pressure on students, but at the end, pretty much all the students, when they're done with the project, they're happy, they're proud. But these projects involve many professors, many students, and you have a big goal. I have one of them called Intelligent Telepresence and Assistive Devices. It's a little too challenging for undergraduate students in their final year. But when you have students from mechanical engineering, electrical engineering, and software engineering in the same team, the team is large, they can take on bigger projects, and these are multi-year. So they take on the project. Each 3-4 years, we switch the project to another one to create more opportunity for creative work. Mm-hmm. But at the same time, these are really projects that simulate the real work environment. Mm-hmm. I love the way we treat the capstone projects. I know a lot of our students, especially in the fall term when they come in, they have difficulty adjusting to it. But when it comes to winter, they perform. And when it comes to graduation, they're all happy and successful. And that's very helpful. In the future, I think we should revise our education system as well with all these computers, information be accessible, distractions, social media. Getting the attention of students is very important. And I think that should be done by each year, one project. Yeah. Projects could be designed to be simple, but the students should apply engineering tools that they learn as they grow into the field. And I think that's something that will probably happen. Mm-hmm. Right now we're talking about it, but I'm pretty sure it'll happen.
Yeah, for sure. I mean, with all the technology we have now, I'm sure even the way it is progressing at such a fast pace, like to change the curriculum every year or every few years would still be quite the amount of work, right? Mm-hmm. But you got to start somewhere.
Yeah, and when it's serious, the students gain the skills, they're happier at the end. I have a course called Mechatronics, which combines mechanical, electrical, controls, software engineering. And I'm giving that course to mechanical engineering students. And I give a project to students. They all build a little robot by the end of the term. Mm-hmm. And it's amazing how much progress they have. And because they define the project, they're part of the definition and execution, they spend a lot of time on that. So probably equal to 2 courses goes into that single course. But that hands-on skill is unparalleled. It's great. They all enjoy it when they build something that works at the end of the year.
Yeah, learning about something and actually building it are 2 completely different things. Like,
we should do a bit more of that.
Yeah, for sure. Especially like as soon as you get into the workforce, that's your job, is creating these real world applications for a need that's present. So that's great. With your work on connected autonomous vehicles, you've studied trust between humans and machines. What have you learned about people and how they decide to trust a robot?
So taking that from the autonomous vehicles, applying it to the robotic side, generally autonomy is the generic word, right? So whether it's autonomous robot or it's autonomous vehicle, so basically you want to program machines to do tasks on their own. Mm-hmm. With that comes the element of trust. And trust is a 2-way thing. You want to make sure the machine is robust enough. So basically to attract the trust of people, your machine has to perform well in different conditions, be robust enough, be accurate, whatever characteristics that you have in mind. Mm-hmm. So it does the task really well and robustly, so it doesn't suddenly break in the middle of the task. Mm-hmm. Imagine if you're in an airplane and the design is not robust. So you would be very unhappy about that situation. So the trust element is there. And so you want to make the machine robust enough so you can actually trust it. Mm-hmm. But there's also the trust or perception of safety or lack of safety from the people. Mm-hmm. That's more about the adoption. Yeah. So even if autonomous vehicles are perfect, still you have a little bit of hesitation to get in one and then let the machine decide how fast it wants to go, where it wants to go, and so on. Right? So it's a 2-way thing. And I think trust in robots maybe not as critical as the vehicles. Because when you go into a vehicle, you're actually at a lot of risk. When you're talking about a robot, if you're talking about a humanoid or some robot around, the chances of that robot, destroying everything in the house is much lower than being inside a vehicle that is going fast.
Absolutely, yeah. Do you think more trust could be adopted if people understood how a regulation was put in place? Like, because nothing can be perfect, right? It has to perform within a set of parameters or like a confidence interval or something. So if people understood that confidence interval, which I actually just learned about this year, and I probably couldn't say exactly what it is right now, but it only works 95% of the time if the confidence interval is... Anyway. You can look it up on your own if you want to learn what it is. But is there a way that we could put more trust in those regulations? Because I don't know of any regulations right now. Say if I'm thinking about the Tesla car, it has to perform within this and this parameter. And you still see, the batteries catching on fire or it going into the meridian. How can people become more aware of how these regulations are put into place?
I think regulation is one thing. Also detecting when, in what situation things could go wrong is another thing. If you have a system that breaks every half an hour, then you know what's wrong and then you fix it.
Yeah.
A lot of these accidents happen because things are working pretty well. And then suddenly there's a situation that engineers or someone didn't account for. A lot of Tesla accidents are like that. That some sensor did not pick up a huge machine because of the lighting condition, because of the camera situation, maybe the dirt on the camera. There is usually these kind of things that cause the accidents. But one thing that is important is also statistics, or that confidence, right? So if you have the proper stats, education, like training people or educating people by providing better information. Right now, we don't have a lot of information to have a proper stat to prove that it's safer than a regular vehicle or not. I'm not advocating for autonomous vehicles, but what I'm saying is that maybe we don't have enough information. We don't know how to compare accidents caused by autonomous vehicles or robots compared to regular workplace or regular driving. Okay. We should have enough information to be able to set that. So yeah, definitely informing people is one thing. Good regulation in place. So if people are sure that the governments are prudent in checking what should be done and what shouldn't. But on the other hand, also you have to give it to the government that, okay, so how much they can do. All of this is new. So unless they know this thing, they can't really set the rules for it, which is the same issue as the AI, right? The government tries to set some rules, but the time it gets approved next year, the AI is 10 kilometers ahead of last year.
Right.
And then you have to catch up with that rule setting or that regulation. So it's so fast paced that you get stuck, right? Yeah.
Right. That could be dangerous though. Anyway. Okay.
But I think all the developers, but all the scientists or developers are doing their best to actually reduce the risk so that you fall into that confidence interval. Right now, nobody asks about the airplanes, right? But there were days that there were more accidents with the airplanes. But now that statistics is there, you know that the general risk of traveling with the airplane is still less than the vehicles. Then you trust, okay, if it happens, it's a pretty bad accident, but the chances of happening is very low, right, compared to vehicles. So I think it's the same for AI, it's the same for autonomous vehicles. But there will be days that I think the risk will be lower. And I believe if there is more and more autonomous vehicles and less manual driving, the complexity goes down because the vehicles have many other ways to communicate with each other that humans don't. We have very limited vision.
Right.
We can't hear things that are coming. We can't communicate very far from where we are. So vehicles can do a lot of that. When we say connected, if they're really connected and they're all autonomous, the chances of accident goes down really, really rapidly.
Right.
Because they know where every other car is, at what speed they're going. So there's no, okay, it passed the red light and I didn't see and I hit.
Right.
Every vehicle knows what every other vehicle does. So that would be a very, I would say that's a big game changer. When vehicles can talk to infrastructure can talk to vehicles again, right? I could be talking to maybe a red light or a piece of camera that is somewhere before the intersection, and then the other car could be informed. So that would be a lot of information that human typically doesn't have that kind of information.
Yeah, because that's beyond sensors, right? That's like actually connecting data. And
exactly.
That's why
there's a lot
of
exchange.
Yeah. Oh my goodness.
Yeah.
So do ethical concerns ever slow down progress, or do they actually make the end result stronger?
It's a very good question. I would say short term, it might. But it's not for a bad reason. It's always for a good reason.
Yeah.
Whenever I pass through ethics, which I do for a few projects every year, they come up with a lot of good questions. Maybe I'm more experienced, but a lot of my students are learning. So those questions or those points that come back, it's part of their education. So they'll learn. I think short term, maybe it does slow down the research, slow down the application, getting the product out. But at the end of the day, it's for the good of everybody. Right. You solve a lot of problems that if you don't solve now or if you don't see them now, they cause accidents later on.
Yeah.
And then the whole thing could be shut down, right? So there's risk either way. But I do believe that we should pay a proper attention to ethics and do it right from the beginning. Yeah.
Absolutely, yeah. How do you ensure technology designed for good isn't misused?
Oh, okay.
Speaking
gosh, that's a very tough question. It's more like saying, how do you make sure the knife in the kitchen that does a lot of good things is not abused? It will be abused. As long as there's abusive behavior among people. It
comes down to who has access to it, right?
Exactly. So it could be using the technology, it could be developing malicious technology, trying to, hack the system. They're there, but definitely there's a lot of research going on cybersecurity, on security in general. So people are working on that, right? Having more robust systems. But when it comes to medical, privacy and a lot of maybe I step back and talk on that one. So particularly when it comes to medical applications, privacy becomes a big issue. Safety becomes an issue. Even accuracy or robustness, right? So let's say you want to use AI to look at some of the imaging from skin or tumors in the body, and you want to detect cancer. So this is very important, right? Robustness is important, safety is important, privacy is important. But then again, if any of these are compromised, whether the system is not robust or security of information, people are concerned about these things. But again, lots of people are working on this and trying to answer these questions.
Right. It's almost like you would want to combine like the intention detection with this as well. Like if someone tries to use it for this reason, it flags something and shuts the project down or something. But I'm sure that would take so much extra data. And
you just define a nice research project, detecting the intent of whoever that is using a machine. Yeah, a little bit closer to what I do for the because in autonomous vehicles I work on the behavior detection as well. It's not just intention; it's behavior as well. So we're running a bunch of research with driving simulator. We're trying to detect, let's say, aggressive driving. We're trying to detect sleepy person. Distracted person. There's so many different behaviors that could risk the driver or the vehicle or other people. And we're trying to detect that. So to some degree, some of the elements are being researched, but going as far as saying for every device, everywhere that someone can abuse, I think the opportunity for abuse is always there. Like, it doesn't matter what the device is. Yeah, it's a hard question.
No,
we can just improve it, make it better. Just keep it out of the reach of children, if you know the abusive people. But if you don't, I think this question exists with all pieces of technology that we generate now or in the future.
Yeah,
and that's something that we need to work on it. But I don't think it would be ever addressed as long as there's abuse.
Right. And I think a lot of the projects, especially the ones that you're working on, are so high value that only professionals that are using that for its intended purpose will get access to it, right? So I'm sure it's easier to mitigate at that extent.
Quite a bit. And with the research going on cybersecurity, on cyber physical systems, you're trying to embed more and more of those safety features into the system, right? Rather than at the gates where you're trying to prevent people from coming in or going out, right?
Right. Makes sense. So if you could fast forward 10 years, what's one way robotics will have transformed our daily lives that people might not expect?
Yeah, that's a lot of pressure on robotics. But I would say One thing for sure, there's going to be more robots at homes, probably in the form of maybe small humanoids. These are basically mobile computers that can do all your computer needs, plus they're mobile. Mm-hmm. So imagine that your computer can walk with you, clean up something, do some of the chores. Also, it's your computer. So if the robot has a very powerful computer, it could be your computer as well. So you basically connect wirelessly to your computer, which is your robot, and then you do all your work, and at the same time get advice. It can talk. It can just maybe put the dishes in the dishwasher. I think bringing it to home is something that is going to change a lot of things in our daily lives.
Yeah.
Not sure if in 10 years, but people are working really, really hard at humanoids. And there is debate. Some people say, you shouldn't just work on the platform, you should work on the application and address the need rather than just make a fancier robot. Mm-hmm. But at the same time, we need both to work, right? Some people are just motivated by making a fancier platform, but eventually you use that for your application. Mm-hmm. So I think that would be one aspect. But I would say more than just home and ubiquitous robotics, it's going to be more into the factories and where we get the job done. That we'll see more of that effect. Is that a mechanic that is repairing the car, or is that going to be a robot? Mm-hmm. The shape and form of the robot doesn't matter.
Yeah.
How the automation in the factory is done. How do I test in the supersonic wind tunnel, which is the project that we just finished with the National Research Council.
Cool.
So there's going to be a lot of robotic applications if you're talking next decade. But I would say it affects our workplace probably more than our home. But when you're looking at maybe 20 years or 30 years, then I would say probably you're looking at a revolution around the home as well.
Amazing.
And robotics, autonomous vehicles are going hand in hand. So I would say if there's anything for you to observe the next 10 years, probably the biggest breakthrough is autonomy of the vehicles. That will change the life quite a bit. Yeah.
Okay, nice. So yeah, look into that for investments, right?
Yeah, we should invest. I don't know if we have the money to invest, but definitely it's an area to invest time and effort, at least to grow with it.
Yeah, fair enough.
Definitely.
Amazing. Well, thank you so much, Mojtaba. That was so many things to think about, and you've really enlightened me into the world of robotics that, it's all around us now with Tesla and everything. That's the only one I know off the top of my head, but now I know where to do more research. So thank you so much for being here today.
Well, thank you so much for inviting me, and this was great questions, and I hope I answered some questions.
Most definitely, yes.
Thank you.